In this video, we're going to see the hybridization of atomic orbitals. So what exactly is hybridization? Hybridization is basically combining atomic orbitals to make hybrid orbitals. Example, we have SP3. So SP3 is a blend of what? Of 1s orbitals and what? And 3 p orbitals. So we have p plus p plus what? Plus p. So now what is SP2? SP2 is also s orbital and 2p orbitals p plus what? Plus p. So this is SP2. What of SP? SP, it is only s orbitals and what? And p orbitals, 1p orbitals. We have s plus what? Plus only p. So now what if I said, what of d square s p what? P3. It is the same thing as having 2d, which is d plus d, and also plus what? Plus s plus p plus also p, which we have what? We have 3p. So what exactly is s orbitals? So s orbital is look like what? It's look like a sphere. And an orbital tells you the probability of finding an electrons somewhere within an atoms. Keep in mind that electrons, they can behave as particles and what? And as waves. So an orbital simply tells you the most probable location in which you could find an electron according to what? According to the Hessen's-Bank uncertainty principle. We cannot know precisely the exact location of an electron. So now let's talk about the p orbitals. P orbitals, there's one s orbitals, but there is 3 different types of p orbitals. We have only one s orbitals, but we have 3 different p orbitals. We have the p of x, which is around the x-axis. We have x. We have another orbitals around the y-axis. So this is what? This is py. And also we have the p orbitals around the x-axis. We have around the what? Around the x-axis. So this is what? This is p of z. So let's talk about the hybridization of carbon. But we have to first know the electronic configuration of carbon. The electronic configuration of carbon is, we have one s here, and also we have what? We have 2s somewhere around here, and also we have what? We have 2p here. So in this stage, we are just going to focus on what? We are just going to focus on this. So let's say the 2s is at the energy level. So this is energy level, and we have 1s here. So let's say, suppose we have 2s at the energy level. So let's say we have 2s at this energy level. So we have 2s. And also we have what? We have 2p here. Carbon has 4 balanced electrons. Now, when carbon forms SP3, hybrid orbitals, it uses all its 4 orbitals. But you have to keep in mind that SP3 means that we need to mix this SP3, which is the same thing as S plus what? Plus P plus P plus what? Plus also P. So where should we put the SP3 orbitals? Should we put them at the same energy level, or with the 2p orbital, or s, or somewhere else in between them? And should it be like halfway closer to 2s or closer to 2p? What will we say? You have to first take a look to this. We are dealing with sp3 orbital. So at this sp3 orbital, s is 1, p is what? P is 3. So I have to say 25%. It is what? It is s. And complete 75%. 75% it is what? It is p, because the p is 3 if we take the average of it. So this is showing that we are going to put sp3 somewhere around what? Somewhere around here, because it is what? It is 25% versus what? Versus 75%. So I'll have sp what? sp3 here. So this is what? That is the main idea behind what? Behind the Horn's rule. So let's say the SP2. So if we move to SP2, we have 2s here. And also we have 2p here. Because we are dealing with SP2, you have to take note that S it is 1 and P it is what? P it is 2. S is 1 and P it is 2. So we have only what? We have only 2P. And you have to take note that in average, what are we going to get? Because we have 1S, so this will now be 33%. It is what? It is S. And also 67%. It is what? It is P. sp2 hybrid orbital should still be closer to what? To 2p than what? Than 2s. But it should be less than sp3. So the 3 orbitals will have the same energy since we use 3 orbitals to what? To make them. So we are going to get 3 hybrid orbitals. So I'm going to put electron in what? In each orbital. So these are the 3 sp3 hybrid orbitals. So therefore we have sp2 and we are going to have what? 3 what? sp2 orbitals. So this is all about what? About the sp2. This arrow, it is showing what? The hybridization. So now let's focus on what? On sp hybrid. So we have 2s here. And also we have 2p here. So after hybridization, to make the sp hybrid orbitals, we need 1s orbitals and what? And 1p orbital. So we are going to use s orbital and what? And p orbitals. sp is the same thing as what? As s plus p, which means the other 2p orbitals are unhybridized, so therefore they will be unaffected. So we have 1s and also we have what? We have 1p. So what will be the percentage? Because there are only one, we have s orbital 1 and we have p orbitals 1. So this will carry, the s orbitals will now be what? Will now carry 50%, and also the p orbitals will now carry what? Will carry also 50%. So therefore the sp hybrid orbital should be right in what? In between the s orbital and what? And p orbital. And there's 2 of them, since we use 1s and what? And p orbitals, or 2 orbitals to make the sp hybrid orbital. There must be 2 hybrid orbital. So if you were to mix 3 atoms orbitals, you should get 3 hybrid orbital. If you mix 4 atom orbitals, you should get 4 hybrid orbital. We are mixing 1s, 1p, that's a total of what? Of 2 atomic orbitals. So that will give us what? 2 hybrid orbitals. So where shall we go into locate our sp? So our sp will be at what? At the middle of what? Of 2s and what? And 2p, because we have 50 what? 50%. So this is what? 2p. We have both 50% and 50 what? 50%. But you have to take note that this is what? This is hybrid. This is hybrid. But this 2p This 2p, it is what? It is unhybridized. And you have to take note that this hybrid, it has what? Sigma bonds. And why unhybridized, it what? It has the pi bonds. So you have to take note of that. By the way, you need to know the hybrid orbitals are used to what? Are used to form sigma bonds. There is one thing that I need you to know. Double bond, single bond, and what? And double bond and triple bond. The single bond, it has only what? It has only one sigma. And also the double bond, it has what? It has one sigma plus what? Plus one pi. And also the triple bond, it has what? It has one sigma plus what? Plus 2 pi. You have to take note that the triple bond, it is more stronger than what? Than this single bond. There is one thing that I want to ask you. Between sigma bond and what? And pi bond, which one is strongest? You have to take note that sigma bond, it is what? It is more strongest than what? Than pi bond. Why? Because you are comparing three bonds as opposed one to one. So these two sigma bonds, let's assume they are equal. But you have to take note that the triple bond going to win because it has two additional what? It has two additional pi bond. So when comparing triple bond versus what? Versus the sigma bond, the triple bond is stronger because you compare three bonds compared to what? Compared to one. But if we compare one sigma versus a pi bond, the pi bond is weaker. It's easier to break a pi bond, but it's harder to break a sigma bond. So just keep that in mind, that the sigma bond are stronger than what? Than pi bond. So let's say suppose I have something like this. So how many pi bond and sigma bond did I have here? So the sigma bond, I have one. I have one, I have two, also I have three, also I have four, I have five, I have six, and I have seven. So I'm having what? I'm having 7 sigma bond, which is 1, 2, 3, 4, 5, 6, and what? 7. But at this point, how many pi bond did I have? I have only this one, which is this, and the second one, which is this. So therefore I have what? I have 7 sigma bond